Hello sir, this is the continuation of my report. Lecture 2, topic Steam Power Plant Cycle. Topics covered to be covered in this lecture are first Carnot cycle, the Rankine cycle, modifications in Rankine cycle. The modification in Rankine cycle are done to improve the efficiency of the cycle or to increase the output of the cycle. And then we will talk about supercritical cycle. Carnot cycle, which was proposed by Nicolas Leonard Sadi Carnot. Carnot was lieutenant in French army and he was an engineer. He was the first person who gave the backup theory of a steam generation. Steam power generation or a steam engine were in existence for the last more than 150 years, and then there was no backup theory for this steam engine. So, Carnot was the first person who gave the backup theory and talked about the efficiency of a steam engine. Nicolas Leonard Sadi Carnot was a French mechanical engineer in the French army, military, a scientist and a physicist, and often described as the father of thermodynamics. Carnot was discovered that a steam engine works not by consuming caloric, but by transferring heat from a warm reservoir to a cool one. Using part of the heat to produce work, the greater the temperature difference between the two reservoirs, the more efficient the engine. And thus efficiency of the steam engine, this is sole publications and the reflection on the motive of fire, which he discussed about the efficiency of a steam engine. And this publication was taken into very much consideration by Lord Kelvin and Clausius while explaining the second law of thermodynamics. It was Thomas Newcomer who proposed the steam engine, in fact, who gave the steam engine which gives the output by reciprocating action. And he had taken ideas from the engine of Thomas Saberly and Papin's pressure cooker. The idea of pressure cooker was given the Papins and the suggested that on in a pressurized speed the cooking is faster. The Carnot cycle. A Carnot cycle, an ideal reversible closed thermodynamic cycle in which the working substance goes through the four successive operations of isothermal expansion to desired point, adiabatic expansion to desired point, isothermal compression, and adiabatic compression back to its initial states. There are three classifications of works: the boundary work, the shop work, and the electrical work. Boundary work occurs when the volume V of a system changes. It is used for calculating piston displacement work in a closed system. This is what happens when steam or gas contained in a piston cylinder device expands against the piston and forces the piston to move. For example, there is a piston cylinder arrangement, a piston right, and there is a cylinder and a piston arrangement is filled with higher pressure gas. The gases will exert forces on this piston and piston will move in this direction. The shop work. It is a kind of contact work because it occurs through the direction materials contact with the surrounding matter at the boundary of the system. A system that is initially in a state of thermodynamics, equilibrium cannot initiate any change in its terminal energy. For example, the turbine. In a turbine, steam is entering from a side and leaving from another side. There is no movement in the system from another side. There is no movement in the system. Boundary is fixed. When the system boundary is fixed, it is known as the shaft work. The electrical work or electrical energy is normally considered to be work energy rather than heat energy. But the placement of the system boundary dictates whether to conclude electrical energy as a work or heat. Second, the system may work on its surroundings because of moving boundaries. For example, in a room, we put a room heater, and when we are doing thermodynamics analysis of that room, right? Suppose in this room we are putting a room heater, and when we are doing thermodynamics analysis of the room, the heater is operative. We will consider the heat transmission to the room is zero, provided walls are insulated. Nakikita natin dito sa picture na to, as we can see on the picture, the boundary work, the shaft work, the surroundings, and the electrical work. The first law of thermodynamics. Yung ibang mga topic dito sa lecture 2 is yung may mga solving, yung mga derivation is kailangan nating separate yung video para maklaro yung explanation. Mahirap kasi magsulat dito sa cellphone, gamit yung cellphone. The Rankine cycle. The Rankine cycle or Rankine vapor cycle is the process widely used by power plants, such as coal-fired power plants or nuclear reactors. In this mechanism, a fuel is used to produce heat within a boiler, converting water into steam, which then expands through a turbine producing useful work. Evaluating principal work in heat transfers. Turbine. Turbine is a device or machine that converts the kinetic energy of a fluid, such as air, water, steam, or other gases, to mechanical energy. The purpose of turbine is to convert the available energy into a fluid that enters it to generate electrical energy. And at this conception, the turbine expands the fluid that enters it, decreasing its pressure or even decreasing its internal energy. Pump. Pump is a mechanical device used to move gases, liquids, or slurries. A pump moves liquids or gases from a lower pressure to higher pressure, and it is responsible for this difference in pressure. Condenser is to allow high pressure and temperature refrigerant vapor to condense and eject heat. In systems involving heat transfer, a condenser is a heat exchanger which condenses a substance from its gaseous to its liquid state. Boiler. Boiler, also known as a steam generator. They are closed vessels in which water is converted into steam through the application of heat. The steam is used for driving steam engines or steam turbines for power generation. Performance parameter. The thermal efficiency gauges the extent to which the energy input to the working fluid passing through the boiler is converted to the net work output. Merong derivation dito, ipapakita lang natin sa separate video na gagawin natin. The net work output equals the net heat input. Thus, the terminal efficiency can be expressed alternatively as another parameter used to describe power plant performance is back work ratio. or defined as the ratio of the pump work input to the work developed by the turbine. The principal irreversibilities and losses. We have the turbine losses, the pump losses, the piping losses, and the condenser losses. Supercritical cycle. We have a supercritical thermal plants where the operation of the thermal power plants take place in the supercritical and beyond the critical temperature. So the entire heat addition takes place beyond the critical point of water. These supercritical plants, they operate on high pressure and high temperature, and they give high output. And then expansion takes place in a rest of the processes are same. Only heat addition in the water takes place in a supercritical zone behind the critical point. And then this is the last topic in lecture 2. Again, yung hindi ko na-discuss, yung may mga derivation is i-discuss lang natin sa another video. That's all. Thank you.